So dear students, let's open our my list class. So this is the name of the project. I just click on it and click on sources, click on the main, just make a room so that you can see it visibly. And this is how we have created our my list class, and I'll go to the private section, which is always a good practice when you are demonstrating. These are the data members. One is called list, which points to a dynamic array, and I've created a constant which is called capacity, and the capacity is 5. This is the problem. We have specified or fixed the size, and we have a size variable which is keeping track of the number of elements currently stored. And under the private section, I have commented that we have to implement the double capacity here. And such a function which is created in the private section of the class is called a helper function. And the client code doesn't need to know about that function because that function is called by public functions or other functions of the same class. So we don't want to expose this function to the clients, right? You have to remember this, that these are not just the data members which could be declared as private, but you can create private member functions. And I think we'll see in graphs and binary trees that we could create many helper functions to help the main functions that we want to export to the client code. So let me go to the top of the file and just explain briefly what we've done so far. We have created a class called mylist, and we have a default constructor, and we are calling it a default constructor because it doesn't take any arguments. And we are doing some initialization. We are creating a dynamic array and storing the address of the first location of that array in the list pointer. So a list actually is a pointer to that array, and we are initializing the size variable to 0. So when we create our object from this class, this code will get executed, and this will be the initial state of our object, size 0 and a new array which doesn't contain anything. Then we created the add member function, which takes an integer value and its return type is void. That means it doesn't return anything. And I have put a comment here as well. That means we have to check if the size is equal to the capacity. That's what we are going today. That's we are adding today. And then, but before this, the implementation is that we just insert a value at the size is 0. So the first index gets a value, and then we increment the size by 1. So the next time add is called, the size will be 1. If it's called again, the size will be 3, and so on and so forth. So whenever we want to add an item or element to the list, we have to then increase the size by 1 because we have declared this size just for one purpose, and that is we want to keep track of the current size of the list. And then we have a print list function which prints the value on screen. The two boolean member functions or predicate member functions, which one checks the underflow and one checks the overflow. We have implemented the insert at, which takes 2 arguments, the value to be inserted and the index at which to insert. And then we have a find or a search member function which can search a value, and if it finds the value, it returns the index of that value. And if it doesn't find, it returns -1, which is not a valid index. And we have a remove member function which takes a value to be removed, and then it removes that value and decrement the size by 1, because once the value is removed from the list, the size will be reduced by 1. And we have a get size which return the current size of the list. We have a replace member function, and we have a very important function called a destructor, which doesn't have any return type like a constructor, which is called when the object goes out of scope and we are deleting the memory from the list. And this was a message I just wanted to display on screen so that you know that the destructor has been called. Now we have to add one more member function, which is called capacity, and in the small letters because it's not a constant, and capacity. And I'm going to show you in a moment that why I'm declaring it. So I'm going to go to the top to my constructor, and instead of passing the capacity, which is a constant, I'm going to assign that constant to this capacity. So the capacity is 5. It will be assigned to this capacity, which is not a constant but variable, and then I'm going to pass this small capacity to this array. And the reason I'm doing this is because I have to then double the capacity, and if it was a constant's value cannot be changed, so I had to introduce a new variable. I could call it anything I want, but capacity means it's a more meaningful name. So if someone else working with me on the same code and he's reading it, he would understand very quickly what do I mean by the capacity, right? Now let's go and implement the double capacity. So I'm going to remove this to do comment. By the way, this is what software's engineers do all the time, the developers do all the time. If they want to, for example, close their laptops and they were working on a piece of code, they would leave comments in different section of the code just as a reminder that these are the things, a task I have to do when I reopen my laptop and start working on the code. So the return type of this would be double, and I'm going to call it double capacity as I demonstrated in the slides. And here I have to double this capacity, and capacity multiplied by 2, and then I'm storing back that new value, which is the double of the original capacity, again in the capacity. And I'm gonna then install, let's call it bigger, a new dynamic array, new int based on this new capacity, right, which has twice the size as the first. And now I'm gonna create a for loop and copy all the elements from the old array. And how I'm gonna do that, I'm gonna say bigger I will get the value from list of I, and we are actually having one data member, a pointer. This is called the list. So our code, all the member functions in this class only knows about list. This bigger is a local variable I've created in this double capacity, right? So keep that on the back of your head. And then I'm going to delete the old array, which is list, because I've already copied values from it, and now I have to update list to point to this new array. So I'm going to just assign the address of the bigger array. So list is now pointing to bigger. And remember, I talked about the stack and the heap. This local variable bigger will be removed from the memory once this function is finished, but the list will not be, because list has been declared at a class level. It's a data member, and a bigger is a local variable. It's not a data member. When we say a data member, that means all functions of the class have access to those variables, right? When we say a local variable like a bigger has been created within this function, it is only visible within the scope of this function. When the function returns, bigger is gone, right? So this is the function that I have to call in two different places. One is the add. So go to the add. I'm going to remove this comment, and I'm going to say if the size equals to capacity, that means the array is full and I have to double the capacity now. That's it. And I think I have to do change in one more place, that is insert. These are the only two functions which insert new values, so that's why I'm putting this code here. I'm going to say if size equals capacity, then call the double capacity member function. And I think that we don't have to change anything else. So let me compile the program. And a green line means a happy line. We have no syntactical errors in our code. So now let's demonstrate, test this program. So I've created a list object from this class, my list. I'm calling the add member functions on the list. And if I, for example, now run this program, it shows 5 values. But if, for example, I add two more values, let's say 600 and 700, and now if I say list.print, it's going to call the double capacity, which will increase the capacity from 5 to 10, and I can now insert 5 more elements. And if I run the code, you will see no problems, and we should see the whole list. And this is the first, and when we added 2 more elements, you can see that, right? There is one more thing we can do. We can create our own another constructor, overloaded constructor. If you want to initialize the initial capacity not to 5 but to, for example, 10, 20 or something, I can come here and say that also. I'm going to say my list int that says cap, and I'm going to simply say that capacity will now be assigned with cap, not with the constant in the default constructor. And I'm going to do exactly the same thing as before, and I can now do something more interesting. I can now say I want to create an object, but this object should have initial capacity of 10, for example. So when we are calling add for the 7 values we are inserting, double capacity will not be called. But if I copy and paste this several times, for example, now it will be called. When we reaches 10, for the 11th item, the add is going to call the double capacity, and it will double the capacity from 10 to 20. So let's run this program and see. Duplicated values we inserted, and you can see the list grows. And if you want to remove an item, you can do exactly the same. You can test this code. I'm gonna give it to you with the slides. So thanks for watching. See you next time.